All right, let's take a look at least A, because you guys said that wasn't too bad. Max, can you talk me through a little bit, and I'll write it up here. All right, hold on, I gotta catch up. All right, all right, and this is where, if you wanted to, you could use the natural log, but log base 10 works just as fine in this case. All right, and then okay, and the step that you did and you just did in your head is you bring the exponent out in front, and now you can solve for t by taking the log of 4.1 divided by 2.6 and dividing that by the log of 1.04. All right, so Max gives us a pretty solid strategy for doing that. Is that okay with everyone? All right. Yeah, go ahead, Tom. Actually, it depends on what the question says or how the directions are stated. If it's like a problem that's in some sort of context, like how many years or what's the amount, you're actually probably going to give me the decimal approximation because I don't know how many years that is. I can't do that on my head. If it says something like, solve and leave your answer as an exact answer, then that's what this is. This is an exact answer. It's not a decimal. It's like a mathematician answer. And I think you should be okay either way. And if the directions don't say, then it's your choice. Okay? Yeah, Keith.
You get a different answer if you have log 4.1 divided by 2.6 than if you did 4.1 divided by 6. That's the log.
Nope. Are you saying if you do 4.1 and then divide by 2.6 and then take the log, that's going to be exactly the same as doing the log of the quantity 4.1 divided by 2.6. You're not listening to me now. It is. It's going to be the same. All right. The actually also interesting thing is it doesn't matter. These two quantities are actually equal. If we had done the natural log of 4.1 over 2.6 divided by the natural log of 1.04, they would be the same. It's important, though, the log of 4.1 over 2.6 is not, the denominators are not equal and the numerators are not equal. But the ratios are equal, right? So it's sort of like saying, 1/3 is equal to, 2/6. The numerators and denominators aren't equal, but the ratios are. Just like in here, the numerators aren't the same, the denominators aren't the same, but when you divide them, you get the same answer. So you can use any base you want. Your calculator limits you to base E or base 10. All right. Which one do we have to use our calculator for? Have you figured that one out yet? Maybe you haven't. Evan, have you figured it out? Yes, you have to use your calculator for C, because on this side, what kind of equation is it on this side? Exponential. And on this side, linear. So if you have an exponential and a linear, you can't do anything with logarithms to make it simpler. If you try to put it in logarithmic form, you get stuck with a t plus 20 in your logarithm. If you go back to exponential form, you end up with a t in your exponent. You have to use your calculator for C, which I think leaves B as a problem we need to do by hand, which I said was medium, but you say is hard. Okay. Someone want to start us off with, the first step's easy. What's the first step, Evan? All right, so we're going to get 1.04 to the t equals 4.1 divided by 2.6 times 1.02 to the t. Now, actually, the next step is pretty similar to Evan's first step. Monty, you want to roll the dice?
Move the 1.04.
Mm-mm. Close. I like you were about to say something that I liked better. Or maybe not.
Divide t.
No. Close, maybe. Travis?
Can we take the natural log of 1.04?
It's enticing to do that. If you let me call on you in 1 step, 2 steps, I'm ready for you. I'm not ready yet. Part of the problem is, whenever you're in, well, actually, go ahead, Peter. You want to take a shot at it?
Divide 1.02 to the t on the other side. Like, put it on the other side. And
Okay. Is this what you mean?
Yeah.
All right. This is what I was going to say, and Peter beat me to it. I was going to say, in algebra, right, the first thing we try to do is get all the variables on one side, right? So can you see how getting the t's over on one side is probably a good idea? All right. Now, I'm almost ready for Travis. Let's see. I'm going to erase to find a little bit of room. Here it is, Michelle. I need to do a little bit of algebra 2 on my left-hand side before I'm ready for Travis. So this is the algebra 2 I'm talking about. What can I do to the left-hand side to make it a little simpler? I wonder if I even have to. Do I even have to? Maybe I don't. I don't have to. I'm going to, but I don't have to. Evan, you want to take a shot at it?
So after we got that, I did the log of 1.04 divided by the log of 1.04.
He's stealing your thunder, Travis. All right, Travis, I'm ready for you. Go ahead. What are you going to do to both sides?
The natural log of 1.04. Don't need the natural log.
All right. You can either use log base 10 or the natural log, but Travis, I like using the natural log. So look, here's what I'm going to do. You can take the natural log of both sides. Now, it's important to understand that you can't take the natural log of the numerator and denominator. When we take the natural log of both sides, we mean you have to take the natural log of this whole side. All right, so let's work it out. I have the natural log of a quotient. Let's simplify it. What's the natural log of a quotient? Whoops. Yeah, you said it right. I wrote it wrong. Okay, so Tom reminds us that the natural log of a quotient is the difference. What can I do with my t's now? Monty says bring them out in front. And I need a clever step now. What do I do? To the left-hand side. I need to solve for t. Okay. Yeah, people are whispering. I don't know what you're saying. You need to factor out the t. If you factor the t out, now you're ready to solve. So do you see how you can now divide? So you can do, whoops. T is equal to the natural log of 4.1 over 2.6 all over the natural log of 1.04 minus the natural log of 1.02. You didn't like that at all? No. Okay. Can I show you something we could have done way back in the beginning? I could have taken a detour right here. This is the same as 1.04 over 1.02 all raised to the t. Whoops. This piece is the same as this piece. And you could have done that and then taken the natural log of both sides, and you would have had t times the natural log of 1.04 over 1.02 is equal to the natural log of 4.1 over 2.6. And you could have divided both sides. It's important to understand, though, look, this piece is the same as that piece. The natural log of a quotient is the difference of the natural logs. Okay? Alright, I apologize. I wasn't setting out to do something that was going to make you so unhappy. It's alright. Monty?
So why wouldn't you subtract for the numerator?
You could. You totally could. Monty's saying, couldn't you say this is the natural log of 4.1 minus the natural log of 2.6 in the numerator? Definitely. You don't have to. Whatever you want to do. They're the same thing. Alright, let's set up 7 and then we can call it a day. I think we have 2 minutes. So for 7, let's get ourselves some room. Prices are increasing at a rate of 12% per year.
So we do see.
Calculator. Y1 and Y2.
Right, so then you just do the intersection.
Yep. Calc intersect. Definitely. Increasing at a rate of 12% per year, how long will it take for prices to double? Well, what's our equation? If we're increasing at a percentage rate per year, what kind of equation? What's the equation of an exponential? Alright, y equals ab to the x. If it's increasing at 12%, can you tell me what b is? 1.12. Do people agree with Sam's assessment that 12% per year is a growth rate, a growth factor of 1.12? What? Oh. Well, alright. Here's the thing. We have to focus on this. How long will it take for the prices to double? Well, what's one of the problems? We don't know what it starts with. As a matter of fact, all we know is that it starts at, right now, A. Sam would say 2A is how much it would double.
No, that's wrong.
No, he's right. Suppose you wanted to say it starts at 100. How much would double that be? Suppose someone else says, no, it didn't start at 100. It started at 50. How much would double that be? Let's do both problems. The first step you do on each problem, so you get 2 equals 1.12x to the x. The first step you do in this problem, 2 equals that. And if you think about Sam was saying 2a equals a to the 1.12. What's the first step you do? 2. So it doesn't matter where it is, as long as you double it, you're going to come up with the same exact equation, right? All right.
Take the logs on both sides.
Yeah, I think so. I think that'll work.
Mr. Bavarian,
Sam.
I have an individualized test question.